Hubble is an upgradable space-based telescope orbiting at almost 600 kilometers, placing it well above most of our image-distorting atmosphere. It takes about 97 minutes to complete each orbit. It is designed to take high-resolution images and accurate spectra by concentrating starlight to form sharper images than are possible from the ground, where the atmospheric twinkling of the stars limits the clarity.
To gather as much light as possible from the faint objects it observes, any telescope needs the largest mirror it can get. Despite Hubble's relatively modest mirror diameter of 2.4 meters, it's well able to compete with ground-based telescopes having mirrors that are 10 or 20 times larger in collecting area. Hubble is a large satellite, about 16 meters long, or the size of a small bus. It's also one of the most complicated pieces of technology ever built. It contains over 3,000 sensors that continuously monitor the status of the hardware, so that technicians on the ground can keep an eye on what's happening. Time on Hubble is a precious commodity. Astronomers around the world regularly ask for much more time than is available. Keeping Hubble operating 24/7 is no small task. Not a second must be lost, and all operations, from observing to the so-called housekeeping tasks, such as repositioning the telescope or uploading new observing schedules, are meticulously planned. For astronomers, the most important components of Hubble are its scientific instruments. There are two groups of instruments in Hubble, here and here. The different instruments serve different purposes. Some are for making images. Some are designed to dissect the light from the stars and galaxies by spreading it out to form a rainbow-like spectrum. Hubble's unique vantage point in space makes it capable of observing the infrared and ultraviolet light that is otherwise filtered away by the atmosphere before it can reach telescopes on the ground. These forms of light reveal properties of celestial objects that are otherwise hidden from us. Some instruments, like ACS, the Advanced Camera for Surveys, are better for visible and ultraviolet observations. Some, like NICMOS, the Near-Infrared Camera and Multi-Object Spectrograph, are best for infrared observations.
Different mechanical and electrical components keep Hubble functioning. The power for Hubble comes from solar panels on the side which convert sunlight into electricity. Gyroscopes, star trackers and reaction wheels keep Hubble steady and pointing in the right direction, not too close to the Sun, Moon or Earth, as they would destroy the light-sensitive instruments, and accurately towards the objects being studied for hours or days at a time. Hubble has several communication antennae on its side that are necessary for sending observations and other data down to Earth. Hubble sends its data first to a satellite in the Tracking and Data Relay satellite system, which then downlinks the signal to White Sands, New Mexico. The observations are sent from NASA in the United States to Europe, where they are stored in a huge data archive in Munich. No single nation could undertake such an enormous project. Hubble has been a major collaboration between NASA and ESA, the European Space Agency, from an early stage in its life. Hubble has been of paramount importance to European astronomy. European astronomers regularly win more than 15% of the observing time with Hubble, resulting in several thousand scientific publications over the years. Two groups of European specialists work with Hubble. There are 15 people from ESA currently working at the Space Telescope Science Institute in the USA, and 20 others make up the Space Telescope European Coordinating Facility in Munich, Germany.